number of divisions. Generate a mesh. That will be adequate. You can turn on thick shells and beams here and get an idea of what our tube looks like. I'm going to set up my structural calculation. I'm just going to grab the edges at both ends and fix them in place. And the last thing I need to do to set up my loading is tell it where is the fluid solid interface. That's that. The analysis settings are pretty straightforward. The time stepping is not actually handled by mechanical. It is handled by system coupling at the workbench level. So what we're going to do is we're going to turn auto time stepping off. I'm going to set this to sub steps. Just tell it 1. Again, these values are not really used. Under restart controls, if I think I might want to restart this and run it for longer, I'm going to tell it to retain files after the solve. And that's pretty much it. This is now set up. This is ready to go. So we'll minimize that. And the next thing we're going to do is create the CFD analysis. I'll grab a fluid flow CFX system, drag it out here, and connect it to the geometry. So I'll use the same geometry. And we'll create a quick fluid mesh on our tube. And just like with the transient structural, where we didn't need the solid and we suppressed it, in creating our fluid mesh, we do not need the surface body, so we're going to suppress that. And I'm going to generate a mesh on this real quick. I like to use, in an application like this, the multi-zone mesher. I'm going to tell it to sweep from the top here. And to get a nice mesh, I'm going to insert a face meshing on that. And last but not least, I'm going to inflate this mesh, this method. And let's make it a total thickness of 2 millimeters and use 3 layers and see what kind of mesh we get. So you can see we got a beautiful swept mesh here, nice mapped quad source face. Target face looks good. This is a very high quality mesh, and we have 14 or 15,000 nodes and elements. The last thing I'm going to do here is set up some name selections that I'll use later. Inlet, outlet. If this were a fluent application, I would also name the walls, but I don't need to here since I'm going into CFX and the default boundary condition will be adequate. So we've got a mesh for our CFD calculation. The way that we're going to do this is we're going to do an initial steady state flow calculation as an initial condition, and then we'll plug that into a transient analysis. So let's open up CFX. Our working fluid is going to be water. We do not need to solve any heat transfer equations, so I will disable them. I'll leave the analysis type steady state for now. Go into my default domain, switch my material to water, turn off heat transfer. I'll leave the turbulence model as K epsilon, it's fine here. Do not need to specify any domain initialization. CFX will figure that out from the boundary conditions. And For my boundary conditions, I have my inlet. Notice I named my boundary condition inlet to match the name selection from the meshing application. It's found that and automatically filled in my